This video is going to take us through what's called a z-score and is a way to figure out standard deviations and what they mean and their different probabilities without the calculator. So a z-score is essentially just the number of standard deviations away from the mean. The formula for finding the z-score is taking the data value minus the mean over the standard deviation. So it's really helpful to know the symbols, obviously, so that you know how to do those calculations. So if we have this first situation, Tim and Lori are in two different Algebra 2 classes. Each section is quite large and the scores on the midterm exams follow a normal distribution. Tim's class, the mean is 70 and his score is 82. So if we want to calculate his z-score with his standard deviation of 4, we're going to do 82 minus 70 divided by 4. So that means that Tim's standard deviation is 3 standard deviations away from the mean. And then in the other class, Lori's class has a mean of 77 and her score is an 89. That class had a standard deviation of 6. So if we calculate her z-score, if you're basing how well they did off of their classes, it looks like even though Tim's score was lower, he did better than the rest of his class because he was 3 standard deviations higher than the mean, whereas Lori was only 2. Now I know for your sake, you're really looking obviously at the better score for your overall GPA and stuff, but if we're comparing to the rest of the class, he seems to have done much better than the rest of the class. So that's really what we're looking at. Okay, so now we're going to look at a standard deviation that's not something exact and how we can use the chart to find our values. So a study finds that the weights of infants at birth are normally distributed with a mean of 3,270 grams and a standard deviation of 600. We choose an infant at random. What's the probability the infant weighs 4,170 grams or less? So that's our data value. Our first thing, we're looking for really the probability. That this infant weighs that amount or less, so that would be less than or equal to the 4170. We're going to first calculate our z-score. So that's telling us it's 1.5 standard deviations to the right of the mean because it is positive. If I were to draw a picture of this, That dotted line is now where that 1.5 standard deviations is falling, and we want to find the area to the left of that. Okay, it's a little challenging for me to shade on the smartboard, but you get the idea. You could probably do a better job of shading it in there. So we're going to use the table to find our probability. Right, and the way that the table works, if you notice the shading on that top part of the table on the front page that you have is to the left. So we're always looking at area to the left. If we don't have that, we need to calculate that correct area. So we're going to look for 1.5. You'll notice we have the 2 decimal places up top and then the 1 decimal place going down the side. So you're going to locate 1.5. And then we're also going to locate any extra decimal places. In this case, it's 1.50, so we'll locate the 0, 0. And then you're looking for where those 2 columns intersect. That's going to be your probability. So actually, the column and the row are intersecting. So we are getting 0.9332 for our probability. Now this probability was rounded only to 2 decimals when we were doing it with our non-exact percentages or the approximate ones that we used from before. But here we are going to get 4 decimal places every time from the chart. So let's try another one where the area is in between because that's a little bit different. So this one we want to figure out the probability that the infant weighs between 2,500 grams and 3,700 grams. So it's good to kind of get an idea of what's happening here. So we're looking for that area in between. Essentially what we're going to be doing is we're going to do the area to the left of the bigger number minus the area to the left of the smaller number. Because if you think about it, if I were to shade the area to the left of 3,700, it would be all of that area. And then the area to the left of the 2,500 is the overlap here. But I want to subtract that off so that I could get just the area that's in between. So I'm going to be subtracting off of that red part from the blue. We're going to want to find z-scores for both of these. And I'm going to assume I'm going kind of quick through these calculations. You will use your calculator to get those calculations. You'll probably be using the 4-function calculator for this. And then for my second one, and then the only difference is the side of the chart we're looking at. If it's positive, we're looking at the front side of the chart because that's on the right side of the mean. If it's negative, it's on the left side of the mean, so we're looking at the back of the chart. So let's calculate the area for each. So for the 0.72, let's go back to our chart. Oops. Sorry about that. I'm going to erase that. We're going to go to 0.7 and 0.02, because if you add that together, you get 0.72. And we find our probability of 0.7642. And if you're not sure which one to subtract from the other, it's always the bigger minus the smaller. So find each of them, and then when you're determining which one to subtract off, do the smaller one from the larger. Right, so notice the back of your sheet has all of the negatives. So we want to get to negative 1.28. Go down to negative 1.2. And then all the way over to the 0.08. So we get 0.1003. So it's a little trickier, and we added in the negative on that section, but it's really just taking those two z-scores and subtracting the smaller from the bigger whenever you're finding the area in between. All right, so you're going to take some time now to try the two classwork examples, and since these notes are posted, once you try the two classwork examples, check your answers, make sure you're on the right track before you move on to the practice.